Okay, here we are at 3c, right? Let's take a look at this. We got 4x plus y equals 1, and 2x plus 2y equals 9. Let's remember, these are two equations. They're two different lines, right? And we're trying to find the x and the y that make both of these true, which if you graphed them, would be the point of intersection. But we're going to try to solve this without graphing. So now look, the x's are lined up really nice. The y's are lined up. The equal signs are lined up. We got the constants over here. One little problem. Now let's go back. Remember 3a? We had this 4 and 4 were the same, okay? So we were able to use this to cancel out the x's. You can't cancel out the 3 and the 5, they don't match, right? But we could cancel out those 4's by adding that negative 4x to the positive 4x. But here, it's not lining up, right? I got a 4 and a 1. It's 1x. We just don't write that. And I got this 1y and 2y. So I can't just add or subtract them. Honestly, it wouldn't be too bad right here just to say minus 4x to both sides. And then plug 1 minus 4x into this y. That could be something you might do. But I recommend just trying to get the same coefficient on both of these. Maybe if you could multiply everything times 4 down here. If you multiply everything times 4 down here, guess what? You'd get 4x. You'd have like 8y and 36 over here. But you'd have the 4's lined up and you could subtract and cancel out those x's. I think that's a good way to do it. I'm thinking maybe about just multiplying everything times 2 up here. So I can get the 2's to match up in front of the y. The y's will have the same coefficient. We could subtract them, cancel them out, figure out what x is. So let's start off with that. Let's turn this y into 2y. Let's get this. Don't look at that stuff up there. Just look at this right here. These two equations. So I'm going to take that 4x. I'm going to rewrite it down here. 4x plus y equals 1. Yo, what am I doing? Plus y. I don't know why I put 8 there. 4x plus y equals 1. I just took this equation and wrote it down here. Okay, what I'm going to do, if I you know how in math we do the same thing to both sides, the equation stays the same. That's why we always have to do the same thing to both sides of an equal sign. So I could multiply, as long as I multiply everything by 2, it's all still going to be the same. Basically, I'm multiplying that side times 2 and this side times 2. We'll have the same exact line. If you graph it, it'll be the same line. Same slope, same x-intercept. Same y-intercept. All that good stuff. Let's multiply it times 2. So we can get 2y. And what this is going to equal, I'll write it down here. 4x times 2 is 8x. And y times 2 is 2y. This is what I wanted. This 2y. 1 times 2 is 2. All right, now we got the 2y here. And I can take this. I could take this original thing that they gave us and write it right down here. Let's take that equation. X plus 2y equals 9. And now, this time we're going to practice subtracting everything, okay? See, they're both positive, those 2's. So that's why I'm going to subtract. Up here, we had a positive and a negative 4. So we added them together to cancel them out. Down here, I got a positive 2 and a positive 2. So I need to subtract this stuff down here. I'm going to subtract all this stuff from up there. We're going to get this minus this. We write it there. This minus this, we put right there. And this minus this, we'll put right there. But the one thing you got to remember, it's minus everything, okay? It's not just minusing the x. When you minus an equation, you got to do the whole thing. We got to distribute this negative to every single thing in here. So, what do we get? We got 8 minus x is 7x. 8 minus x is 7x. 2 minus 2 is 0. Whoa, look at that. That's what we wanted. The y's went away. They're gone. It's going to be so much easier to solve for x because now we don't have a whole line to worry about. It's not a whole graph of a line. It's not a whole bunch of combinations of x's and y's. We can kind of tie this thing down to a single x and y. 2 minus 9. Negative 7. The 9 is bigger than the 2, so that's why it's negative 7. And now we're going to try to get x by itself. I've got 7x. I don't want 7x. I just want 1x. So if I divide by 7, if I divide this by 7, I'll get x by itself down here. Because it's 7 divided by 7 is 1. There's 1x down there. But remember, if we do something to one side, we got to do it to the other. So I got to divide this side by 7. And 7 divided by 7 is 1. But we got a negative divided by a positive. Negative 7 divided by positive 7. I'm pretty sure it's going to be negative 1. And now we're doing good. We found out what x equals. X is negative 1. Now let's take it and let's plug it back in. I say we take this thing, this negative 1, and swap it out for that x right there. Find out what y equals. So let's just rewrite this thing over here. Sorry about too many colors. X plus 2y equals 9. And we're going to swap out the x for negative 1. I just took this right here. This equation, I'm swapping out the x for negative 1. So let's put it in there. Negative 1. I'm going to make it orange. Plus 2y equals 9. I made it orange to emphasize where did this come from. It's right down there. This is what x is. So I can trade it with that. But remember, we got to combine like terms. I got negative 1 over here. It's supposed to be over there with his buddy 9. But for some reason, he's kicking it over here with the 2y. And these guys will never mix. 2y is a variable, and negative 1 is a constant. He belongs over there with the other constant. So let's send that negative 1 over to the other side. And the way we do that is we're going to add 1, right? To cancel out that minus 1. Well, plus 1. And we do the same thing to both sides every time. Now we got 2y equals 9 plus 1 is 10. And we got one more thing. I got 2 times y. That's multiplication. And we are going to do an inverse operation. Inverse means the opposite. The opposite of multiplication would be division. Let's divide both sides by 2. It's going to cancel out that 2. I'll have 1y equals 10 divided by 2 is 5. And here we go. There's our 2 answers. We could write this as a coordinate pair. Our solution to this system of equations is x is negative 1 and y is 5. And if you plug these numbers back in to both of those original equations, you plug in the negative 1 for x and the 5 for y, it's going to make both of these things true. They'll be correct when you plug those in. And that's what a solution of a system does. It makes them both correct, and it shows where the intersection point of their graphs would be.